Welcome to The Explainer. Today, we're flipping the script a bit. When we talk about the energy transition, our minds almost automatically goes straight to green electricity, right? Solar panels, wind turbines, electric vehicles. But today, we're tackling a completely different, often overlooked challenge: green heat. We're constantly hearing about wind and solar power breaking generation records. But to truly understand the net zero transition and why we aren't quite there yet, we need to ask ourselves a pretty fundamental question. What massive piece of the puzzle are we completely missing? If our grid keeps getting greener, why are global emissions still such a staggering problem? Get this, literally half of all global final energy demand is for heat, not electricity. Half. And here's the kicker. Right now, renewables only account for about 13% of that massive heat consumption. We are essentially trying to solve a giant puzzle while completely ignoring half the pieces. So here is how we're going to break this down today. The industrial heat problem, what is thermal storage, fixing the power grid, real-world storage solutions, the economics of heat, and finally, the net zero future.
All right, let's jump straight into part one, the industrial heat problem.
Heavy industry is an absolute beast when it comes to emissions. Industrial process heat makes up about 24% of global energy-related greenhouse gases. Why? Because making the stuff that builds our modern world, metals, cement, glass, takes an unbelievable amount of thermal energy. And for the most part, they are still relying almost exclusively on fossil fuels to get it. And here's why it's so incredibly tough to change. We're not talking about heating your living room here. These industrial processes require extreme temperatures, sometimes up to 1,300 degrees Celsius. Plus, these factories usually run continuous 24/7 operations. So sure, direct electrification is technically feasible, but without a way to be flexible, running 24 hours a day means exposing these factories to absolute monster electricity price spikes during peak hours. Which leads us perfectly into part two. What exactly is thermal storage? Thermal energy storage, or TES, is basically the silver bullet here. Think of it as a giant shock absorber for the power network. A TES system soaks up dirt-cheap, abundant renewable energy from the grid when the sun's shining or the wind's blowing, converts it into heat, and traps it in super-insulated materials. Then it can unleash that heat, again up to 1,300 degrees Celsius, exactly when the factory needs it, even if the wind died down hours ago. Let's zoom out a bit for part three, fixing the power grid. We really need to talk about why our aging power grids desperately need these giant shock absorbers right now. All this rapid expansion of renewable energy is awesome, but it's causing severe growing pains. We're seeing massive grid congestion that wastes billions of dollars. We're seeing frequent negative electricity prices because we sometimes generate more solar and wind than we can actually use. And we're seeing epic bottlenecks just trying to plug new renewable projects into the system. To put that bottleneck into perspective, there are 3,000 gigawatts of renewable energy projects just sitting in line globally right now waiting to connect. And they face a median cost of $46 million per gigawatt just to plug in. That's largely because the grid requires crazy expensive upgrades just to handle the fluctuating power. But if we can add flexibility to the grid, we can slash those upgrade costs drastically.
Okay, let's move to part four, real-world storage solutions. Because this isn't just theoretical, it's happening today.
Take Craftblock, for example. Their proprietary thermal energy storage system converts electricity into heat and stores it in this wild, sustainable, newly invented material that easily handles 1,300 degrees. When they need the heat, they literally just blow cold air through the storage. The discharged air is adapted to the exact temperature needed, plugging seamlessly right into a factory's existing setup. Over in Berlin, Vattenfall and SaltX have launched a 10 megawatt-hour salt battery pilot plant. They use a patented nano-coated salt that can be charged thousands of times. The craziest part? It can hold on to that energy for weeks or even months without losing heat. This is a massive step in Vattenfall's plan to completely ditch coal in their Berlin heating operations by 2030.
And it's not just the new tech startups innovating here. Established players are on it too. Cannon Boiler Works uses industrial steam accumulators to store high-pressure steam. So for industries like rubber manufacturing or food processing that need quick, intense bursts of steam, the accumulator handles it. That smartly saves the main boilers from severe, damaging wear and tear.
Now you might be wondering, why not just use giant lithium-ion batteries?
Well, batteries are fantastic for storing electricity to use as electricity. But if your end goal is heat, thermal energy storage absolutely blows it out of the water financially. We're talking a lifespan of 15,000 cycles with zero degradation. It uses totally standard, uncritical materials, holds heat for longer durations, and the round-trip efficiency for direct heat use is just vastly superior. Let's talk money in Part 5, the economics of heat. This is where energy arbitrage, buying cheap and avoiding peak prices, gets really fun. Let's say a factory needs 50,000 megawatt hours of energy a month. By shifting 18,000 of those to off-peak charging using thermal storage, a factory in Spain slashes their energy costs by almost 70%, saving nearly 690,000 euros. But down in Australia, it's wild. A factory there actually generates a profit of over $1.6 million just by soaking up negative-priced electricity. Wait, negative prices? Yep. In Victoria, Australia, back in January 2024, off-peak prices hit negative $24 a megawatt hour. Thanks to a ton of solar generation mixed with old, inflexible coal plants, there is literally too much power on the grid at times. So the grid will actually pay a factory equipped with thermal storage to take that power off their hands so the whole system doesn't overload. And this unlocks completely new business models, like heat as a service. An energy provider can actually own the thermal storage unit installed at a factory, sell the factory stable, fixed-priced heat, and then play the energy markets on the side. Just by helping the grid stabilize its frequency for 30 minutes a day, soaking up excess power to prevent a blackout, the utility can rake in an extra 164,000 euros a year. It is a total win-win. Bringing us to our final section, the net zero future. How do we actually scale this globally? Well, the good news is global regulators are wide awake to this and are actively helping to de-risk the investments. We've got major policy drivers now. The U.S. Inflation Reduction Act is dangling $6 billion in competitive grants for advanced decarbonization. The EU's emission trading system is making fossil fuels increasingly expensive to level the playing field. And the UK's Industrial Energy Transformation Fund is directly funding these low-carbon tech upgrades. What we are really looking at here is a viable pathway to a truly sustainable, flexible, and decarbonized industrial landscape. Thermal energy storage doesn't just cut emissions, it makes our entire energy system ridiculously more resilient. It takes the massive load off our struggling power grids, drives down production costs, and shields heavy industry from crazy energy market swings. So as we push aggressively toward a net zero future, it's time to take a step back and ask ourselves something. Are we so obsessed with greening our electricity that we've totally ignored the real silver bullet here? Rethinking our approach to industrial heat might just be the absolute most critical step in saving our overloaded energy grids and actually hitting our climate targets. Thank you for exploring this with me today on The Explainer.